Okay, good morning, all of you. Today, we have to discuss composite materials. Composite material means that is the combination of two or more phases. Already, we have some idea about composite materials. Okay, yes, composite materials. Yes, first, before going to composite materials, then let us discuss the contents. Contents of composite material is that is the definition, background, natural composite, early composite, modern example, advantage, disadvantage, applications, and classification. Right? Composite uh, means a broad definition of composite is two or more phases. Okay, that is the reinforcement and matrix combinedly we can form the composite material. Yes, a broad definition of composite material, two or more chemically distinct material which when combined have improved properties over individual properties. Yes, composite could be natural or synthetic. Yes, here reinforcement and matrix two combinedly you will get the composite. If you see this slide here, reinforcement. What are the properties of reinforcement? Matrix. What are the properties of matrix? Both combinedly it gives to the composite properties. Right? Actually, here matrix. What is matrix? It surrounds. Matrix means some binder. It always sticks to the reinforcement. Yes, it surrounds and binds together reinforced material. Matrix phase may be metal, ceramic, or polymer. Okay. Yes. Next one is the reinforcement. Reinforcement is generally you will use fibers. Yes. It gives strength and stiffness to the matrix. Okay, composite material. Okay, usually the classification that is fibers are generally we will use glass, carbon, organic, boron, ceramic, or metallic fibers. You will use in composites. Okay, then here the characteristics and hello, come in. Characteristics of composite materials. Yes, here composite materials and that is the fiber based and that reinforcement based, matrix based. Here different types of fibers are there. Glass and graphite, boron, aramid and others. Go Chandu sir. Okay, na. You Chandu sir and I will come. Okay, that can. Yes, that is the glass fibers. What are the different characteristics of glass fibers? That is the high strength and the low stiffness, high density. Okay. Yes. At the same time, the good that is the advantage is that is low cost. Okay. So what are different types of glasses are available in market is E-glass and S-glass types commonly used. Next one is the graphite. Graphite is available as high modulus or high strength but low cost, less dense than the glass. Next, boron. Boron fibers have high strength and stiffness, high density but high cost. Aramid or Kevlar fibers. Aramid and Kevlar fibers, you know, that is the new type of fibers. Strength to weight ratio is high compared to for all the fibers, despite that is the high cost. Okay. Yes. Here other fibers: nylon, silicon carbide, silicon nitride, aluminum oxide, boron carbide. These all are the ceramics. Okay, we will use ceramics also for fibers. Next one is the matrix materials. Matrix material generally will use that is the thermosets, thermoplastics. Thermoset, one of the best is epoxy resin or polyester. Yes, commonly used. In few others are phenolics, fluorocarbons, polyether, chlorine, silicon or polyamides. Next, thermoplastics, that polyethylene. Polyethylene covers that are thermoplastic. These are Uh, uh, thermoplastics are more flexible than the thermosets, are tougher than the thermosets. Next, metals and ceramics also can use for matrix material. Yes, first of all, let us discuss that is the background of composite materials. What is the background of composite material means? That is the natural composite. First, our forefathers they had used natural composites. The natural composites best example is wood. Yes, in wood particularly, cellulose is the fibers reinforcement and the lignin is that is the matrix. Cellulose is also found in cotton but without lignin. Okay, the bone, yes, our own human body is one of the best example of composite. That is the yes, bones. Bones are reinforcement and flesh that covers the bones. That is the matrix. Okay, next, early composites are example is the mud bricks. Particularly, these mud bricks are used to build the houses in olden days. How to prepare this mud bricks are, you know, in this one straws are there, small cut of pieces that is combined with mud. Okay, then here the straws acts as the reinforcement and mud is the matrix. Okay, another best example is uh, we are constructing houses, particularly while constructing the house, that is the roof is there, slab. A slab is the best example of composite, in particularly in slab, the concrete. The concrete is the matrix and steel parts, steel bars or rods are reinforcement. Yes, actually, here concrete covers the steel rods from the environmental effect. But the steel rod ultimately it gives the strength to the composite. Okay, next one is modern examples. Modern example, best one is the composites is fiberglass. Yes, these fiberglasses are used in so many applications. In this fiberglass, the fiber glass fibers are reinforcement material and plastic resins are that is the matrix. Okay, in this one, the plastic matrix holds the glass fibers together and protects from damage by sharing out the forces acting. Yes, these are extensively used in boat hulls, sports equipment, building panels, and many car bodies. Next one is the carbon fibers. These carbon fibers are lighter and stronger than the fiberglass, but expensive. Yes, these are used in aircraft structures and expensive sports equipment. Next one is the carbon nanotubes. Yes, these are even lighter and stronger than ordinary carbon fibers, but they are still extremely expensive. However, offer possibilities for making lighter cars and aircraft using these carbon nanotubes, right? That example is in new Airbus A380 is the best example of this A380 Airbus. Okay, see here one aeroplane can be seen in this slide and different parts can be seen. Yes, here all the parts mm, are made by composite material. We can see that is in the slide engine strut fairings that are the Kevlar fiberglass, environmental control system duct that is the Kevlar. Next one is the here you see body main landing gears graphite. Like this, it's all the parts nearly made by that is the composite material, right? Okay, next slide. See here advantages. What are the different advantages of composite material? Already I told you best advantage is the composites have high strength to weight ratio. High strength, low weight. That means that's why composites are using in so many applications, aerospace, next sports equipment, Next one is the automobile. Next, so many. That is the defense application. So many applications. Then we are using composite materials. Here, composite materials have higher specific strength than many other materials, particularly alloys. You can see here the slide two um, two here boxes and a comparison of different alloys as given wood, aluminum alloy, titanium, steel, and E-glass composites, S-glass composite, aramid, and HS carbon composite like this. Yes, particularly come to the composite compared to others, uh, they have more strength, specific tensile strength and tensile modulus. Okay, the lowest properties for each materials are associated with simple manufacturing processes and material forms. Okay, here that are manufactured using spray layer process, particularly glass fibers. Next, higher properties are associated with the higher technology manufacturing that autoclave molding of unidirectional glass fiber used in aerospace applications, right? Next one is the design flexibility. Okay, design flexibility means in the name total meaning is there design flexibility. Whatever shape we want, we can manufacture that component. Even complex shapes can be also manufactured using composite materials. Okay, that's why this gives a designer freedom to create any shape or configuration. The best example of this design flexibility, boards are good example of the success of composite material. Next one is the corrosion resistance. Yes. What do you know about corrosion? Can you tell? Corrosion means daily life. In our daily life, we are observing so many outside pots that are undergoes corrosion. That means when you keep any object outside, that is in environment, then after a few days, automatically you will see there may be some formation of rusting. Yes, the rusting means then it degrade the material. That is called corrosion. Corrosion is a very dangerous, particularly in materials. Okay, that's why when you purchase any component, okay, first and manufacture any component, we should see first is it having corrosion resistance or not. Okay, yes, particularly in this one, composite products provide high corrosion resistance, that is long term resistance to severe chemical and temperature environments. Particularly environments means you see seashores, there may be chances of forming due to the climate situation, the moisture forms the rusting of the parts. That's why that is corrosion resistance. It plays vital role, particularly in that areas. Okay, that material. Next, chemical plants, chemical exposure. Due to the chemical exposure, there may be also so many reactions that take place. Due to that, there may be formation of corrosion. Okay, yes, composite materials of choice for outdoor exposure, chemical handling applications, next severe environment service. These are the corrosion. This is the corrosion resistance. Next one is the low relative investment. One reason the composite industry has been successful is because of low relative investment in setting up a composite manufacturing facility. Right. Durability. Durability also very good property for composite materials. Composite products and structures have exceedingly long lifespan. Yes. Coupled with low maintenance requirements, the longevity of the composites is the benefit in critical applications. In a half century of composites development, well designed composite structures are yet to wear out. In 1947, the US Coast Guard built a series of 40-foot patrol boats using polished resin and glass fibers. These boats were used until the using polished resin and glass fibers until the early 1970s, when they were taken out of service because the design was outdated. Okay, yes, that is the best example of composite material of the durability. Extension testing was done on the laminates after the decomposition, and it was found that 2 degree of the original strength was lost after 25 years hard service. Okay, when the time is going, automatically materials that are getting the strength low. Okay, this is natural. Okay, particularly in composite material also that will happen. That's why durability, this advantage is a very important in composite material. Yes, in the same way, disadvantages also there. Composites are heterogeneous, right? Heterogeneous means the properties are not equal. Okay, properties in composite vary from point to point in the material. Most engineering structural materials are the homogeneous, but composite materials are heterogeneous. Next, composites are highly anisotropic, right? Yes, anisotropic means the strength in composite varies as the direction along which we measure, okay, changes, right? As a result, all other properties such as stiffness, thermal expansion, thermal conductivity, electrical can keep resistant also anisotropic. The experience and institution gained over years about the behavior of metallic material does not apply to the composite materials, right? Next one is disadvantages. Particular composite materials are difficult to inspect with conventional ultrasonic eddy current and NDI methods such as radiography. In American Airlines Flight 587 broke apart over New York on November 12, 2001. 265 people died. The Airbus A3000 wood high tail pin tour. Okay, much of the tail pin was made of graphite composite. The plane crashed because of damage at the base of the tail that had gone undetected despite routine non-destructive testing and visual inspections. Right? Yes. Another one example is in November 1999, Americans Cup boat, right? Yanks American broke in two due to rebounding phase in the sandwich structure, right? Yes, here so many applications of the composite materials. Everywhere we are using composite material. Yes, it can be seen the slide, aeroplane, aerospace, automobile, boat building, infrastructure, wind power, big sports. Okay, these all are the applications of composite material. Okay, next one. Here, in addition to the application of composite materials, bicycles, sports bikes. Next one is the bridges, pedestrian bridge in Denmark, 130 feet long. Okay, that is built using composite materials, right? Yes. See, application of composite in the aircraft industry in 2000, the Boeing 777 aeroplane was built 11% of composite, 70% of aluminum, 7% of titanium, 11% of steel, 1% other. But come to the days are goes that usage of composite has increased. That is Boeing 787 Dreamliner that is made in 2007 In this one, 50% of composites. See how drastically increased the usage of composites, and 20% is aluminum, 15 is titanium, 10% is steel. Okay, when you see this slide, how you can understand the usage of composites, how it has increased, that is the wonder. Okay, see next one, let us discuss, that is the classification. What are the classification? Yes, two types. The composite can be classified into two types. One is the fiber based composite, next one is the matrix based composite. Fiber based composites are particle reinforced, fiber reinforced, structural. The particle reinforced composite, large particle dispersion strengthened. Next, fiber reinforced continuous and discontinuous. Laminates. Next one is structural or laminated sandwich panels. Okay, these are the classification of composites based on the fiber. Next, matrix based, that is the four types. That is the polymer matrix composite, that is the PMC. Next one is the ceramic matrix composite, that is the that is the CMC. Next one is the metal matrix, MMC. That is, next one is the CCC, carbon carbon composites, that is total matrix based composites. Okay, then see here, reinforcements. Reinforcement, generally you will use, that is the fibers, continuous fibers, discontinuous fibers, particles, fabrics. You can see this slide, and you can easily understand. And continuous means without gap between, that we continuously, then the length is more, I hope you see. That is the discontinuous, that is the gap between, that is the some small pieces like in same line. Discontinuous means in the disorder, discontinuous randomly oriented fibers, small pieces. Okay, yes. Next one is particle reinforced composites. What do you know about particle reinforced composites? One form of composite is the particulate reinforced composites, the concrete being a good example. Okay, the aggregate of course rock or gravel is embedded in a matrix of cement. Okay, that cement is the, that is the matrix. The aggregate provides the stiffness and strength, while the cement acts as a binder to hold the structure together. There are many different forms of particulate composites. The particulates can be very small particle less than 0.2 microns. Choked fibers such as glass, pallets, hollow space, or new metals such as bulky balls and carbon nanotubes. In each case, particulates provide desirable material properties. The matrix acts as a binding medium necessary for structural applications. Right? I hope all of you understood what I have discussed so far. Okay, then I am closing this section. Thank you very much for your patience listening.